go through this question in a couple of different ways. The first way doesn't require lots of advanced methods, but there's a little bit to think about to start with. And the second way is a bit more technical, but I think it also works quite nicely. You can decide which you prefer. We've got a square of side length 4, let's say it's this one on the right, and then one of 5. We're told that the area of the triangle at the bottom is 8, and we're asked to work out the area of the parallelogram. Now, if I draw a line going down this parallelogram, then I'm going to say that this is a green angle. I've got a purple angle, and then below I've got I'll go blue. Okay, those three angles together are going to add to 180 because I have two right angles here, which gives me 180. So the others must be 180. That's something to be aware of. Now, because it's a parallelogram, we've got these parallel sides, that Z there, then this is also purple. It's the same as that purple angle, and this is also green, which means because I've got a triangle now and the angle's out to 180, this must be blue and this must be blue. Also, this is 5 because it's a parallelogram, and this is 4, and we have three congruent triangles, in fact. This is 8, and this is 8 as well, because we have the blue angle is really where it's all about. We've got 5, 4, and then a trapped angle, so we're using angle, side angle. Do you know what I said? It wasn't technical, and then bringing in congruent triangles, which is, hopefully a topic you have seen, but there's all these like rules that you have to know for it. Anyway, once you've realized that, it's just 8 plus 8, which gives you our answer of 16 for the parallelogram. Method 2 now, this is how I did it. I decided to split the parallelogram this way. And then notice that if I call this angle C, and this is 5 and 4, then I can use a half AB sine C to get the area of the triangle, which we know is 8. That becomes 10, so sine C is going to be 0.8. Okay, you'll see why I'm doing this in a minute. This angle here, as explained before, is going to be 180 minus C. And now this is also 5 and this is 4. So the area of the triangle here is going to be a half times AB sine C again. It's the same numbers, but now I've got sine 180 minus C. And of course, for the whole thing, they're exactly the same. They're congruent. Remember, the opposite angles of parallelogram are the same, so I'm again using the angle side angle idea. But that was also more of a common fact that you can split a parallelogram to two to create two congruent triangles. So overall, I'm just then going to times my answer by 2. Okay, so those cancel. Now, here's the bit that's a little bit more technical. We have to think about sine 180 minus c. So drawing the sine graph, if I have an angle here at c, then because of the symmetry of the curve, if I do 180 minus c, which takes me to here, I get exactly the same value of sine. In fact, that's how you find solutions to trig equations. So I can replace this by sine c. I can hence replace it by 0.8. So I'm doing 20 times 0.8, which is going to give again 16. So just a different way to think about it. But yeah, well done either way.